Welcome back to my session 3, and today's session is based on the analysis and conversion of different types of coordinate system. Myself Dr. Sayanti Chatterjee, Associate Professor of Institute of Aeronautical Engineering, Hyderabad. Today I am going to start this topic, conversion of different types of coordinates. Today I will tell about the different type of coordinate system and what are the properties of the coordinate system, and lastly I will tell about the conversion from one coordinate to another coordinate system. So according to our CO, this is also comes to the Bloom's taxonomy apply, and we will use the vector calculus and other mathematical techniques, and it will be helpful to describe the electromagnetic phenomena. So let's start the coordinate system. What is a coordinate system? When we will tell a car is moving with a 50 km per second and the car is at 5 meter distance. Now question will come, 5 meter means with whose respect it is 5 meter? This is a valid question. If I tell the college is 5 kilometer, so another question will come, from whom it is 5 kilometer? When a plane is moving in the air, it has also some point. It has some height, it has some x-axis, that is roll, some axis, and pitch means height. So everything what we are telling has the coordinate system. According to the definition, coordinate system represents a point in the coordinate space. Coordinate space means with respect to origin, with respect to one constant point, what is the position of this. So what is the need for the coordinate system? To describe a vector accurately and to express the vector in the terms of its components, it is necessary to have some direction, and this is the need for the coordinate system. Such directions are represented in the coordinate system. What does it mean? See, we on our desk we kept a pen like this. The pen is 5 meter from the y-axis, means if this is the side, one is 5 meter from the axis and another one is the 3 meter from the axis. So 5, it is 5 from one side and 3 from other side. So what is its coordinate? Its coordinate is 5, 3. So it is the position, and if we write it in the vector term, it will be 5x hat plus 3ay hat. As we know from the previous lecture that the unit vector along x-axis is ax hat and along y-axis is ay hat. Now we will try to start the coordinate system. What is the coordinate system? Basically, coordinate system can be divided into two categories. One is known as the orthogonal, another one is the non-orthogonal. What is the meaning of orthogonal coordinate system? Orthogonal coordinate system means all the axes are 90 degree apart. All the axis means the directions are 90 degree apart. And we will also discuss about the non-orthogonal system. Non-orthogonal system means the axes are not 90 degree apart. In our generally non-orthogonal system is basically used for the spaceship and the higher end application. Whatever we use in our daily life is the orthogonal system. So the orthogonal system has again divided into the three categories of the coordinate system. First one is our own popular, that is the Cartesian and rectangular coordinates. And what are the value? What are the axes? The axes are the x, y and z. What are the They are basically X, Y and Z. We can take the example of the mobile. This is a 3-dimension thing. So this is our x-axis, this is our y-axis and the height is the z-axis. So any 3-dimensional thing we can divide into 3 axes. One is x, one is y, another one is z. So generally for our daily life we use the rectangular or Cartesian coordinate system. Next we will move to the cylindrical one. What is cylindrical? As an electrical engineer, we can give one good example of the cylindrical coordinate system. Cylindrical coordinate system is the current carrying conductor. Current carrying conductor looks like a cylinder. Cylinder means any conductor have any long line connecting wires. These are have the cylindrical coordinate. Cylindrical coordinate, we can give the example if we think about the pen. This is the good example. This is the good example of the cylindrical coordinate system. So it has also 3 parameters. One is this circle, another one is the height. So what are the parameters? What are the axes we can write? The axis is the radius of the cylinder. If we think the radius of the cylinder, which can be written by R, or some book it can be written by rho. We can use the both nomenclature, either R or rho, which is basically the radius. Then we can think about the angle. As this is a circle, it has some angle, and the angle is always written by phi, the angle, and the height or length, it is the z. So you and always the radius, height and the angle are 90 degree apart to each other. So this is a good example of the coordinate system. Now third one is the spherical system. Spherical system means this is basically a circle, sphere. Though it is a hollow thing, but we can assume this is a spherical things. So spherical things has also 3 coordinates. One is the radius. One is the radius. If you see this bangle, this is the radius from the origin. This is the radius. This is the height of the sphere. This is the height of the sphere. And if it is the circle, it has some angle also. So the angle is phi. And height. Height you can see, this is the height is not linear. Height is basically curvature in the case of a sphere. So we can write the curvature as the theta. So we can tell the coordinate system has the 3 part. Coordinate system, orthogonal coordinate system is basically 3 types. One is the Cartesian, one is the spherical, and another one is the cylindrical. What is the example of the spherical? Our Mother Earth. Mother Earth is a good example of a big sphere. And as an electrical engineer, we can give the example of the charge, one molecule. It also looks like a proper sphere. It has also 3 coordinates, R, radius, phi, angle and theta, the height of the system. So first we will start with our basic coordinate system, which is known as the Cartesian coordinate system. The basic coordinate system is known as the Cartesian coordinate system, and you can see it has 3 axes, x, y, z. Sometimes also we can draw like this, x, y, z. Both are correct, but we will generally use this one. So x, y, z, and you can see the x, y, z all are 90 degree apart. So what is the importance of coordinate system, especially Cartesian coordinate system? It is very convenient when dealing with the problems having rectangular symmetry. See, we are thinking about the room. In the room, this is a rectangular in nature. It has a rectangular symmetry. So in this we will use the Cartesian coordinate when we are thinking about a field, about a space, about a surface. We will think only about the Cartesian coordinate. That's why the another name of the Cartesian coordinate system is the rectangular coordinate system. So as I discussed earlier, the system has the three components. One is x, one is y, another one is the z. So the system has three coordinate axes. One is x, one is y, and another one is z, and they are mutually perpendicular to each other. So we can tell they are perpendicular to each other mutually. And the three axes are met at a common point. The three axes met at a common point, and this point is named as the origin. All of you know this is the basics. All of you know from our childhood that this point is known as the origin. And what is the coordinate of the origin? The origin is 0, 0, 0. The x-axis value is 0, y-axis value is 0, and z-axis value is 0. Next, so when we are thinking about the coordinate system, there are two types of Cartesian coordinate system. One is known as the right-handed system, or we can tell it the right-handed screw rule. So one is the right-handed screw rule, another one is the left-handed rule or left-handed screw rule. So Cartesian coordinate always follow the two rule. So first we will discuss about the right-handed system. So what is this right-handed system? You can see there are three axes x, y, and z. We can see there are three axes x, y, and z. They meet at their origin. They met at the origin of the system, and if we think about the origin of the system, there are three axes x, y, and z. And right-handed screw rules means this is we will take x to y, right-handed screw, x to y, y to z, z to x. What is the thing? It is x to y, y to z, and back z to x. So this is called as the right-handed screw rule. And according to the right-handed screw rule, it is basically the anti-clockwise direction. The direction is basically the anti-clockwise direction. We will take it as the positive. Similarly, if we go in the opposite side, means if we start x to z, z to y, and y to back. So this coordinate system means if we go in the clockwise direction, x to y, you can see x to y. If this field, if you think about the paper from x direction to y direction, the z direction is always in the downward. So the direction is always downward, and this is called as the left-handed screw rule, and it will always go in the minus 90 degree direction, or we can tell it will go in the clockwise direction. So when we are thinking about this, what is the range of x? So any point can be positioned at here, anywhere we can keep the point. If say we are giving the example, my home is 20 kilometers from the institute. If the institute is the origin, so what is the distance? 20 kilometer, another point maybe it is 100 kilometer apart. So the point, the range of x, y and z axis is infinity. The range of x is minus infinity to plus infinity. What is the range of y? Y axis we can change from minus infinity to plus infinity. And z axis, sometimes we feel what is the meaning of height in negative. Negative is nothing but if anything is underground. Say if we keep the pen like this, the upper, if my hand is the axis, the top portion from my hand is the positive z and the downsides of my hand is the negative z. And if we take the ground, if we take the field as the axis, so if it goes to the underground, we can tell it the minus z, and minus z is minus infinity to plus infinity. Next, what is the coordinate according to the unit vector? So already we have told that according to the x-axis it is a exact unity vector. What is the meaning of unity vector? It is the direction vector. It has only direction and magnitude is 1. What is along the y-axis? It is AY. What is along the z-axis? It is basically AZ. So we have three axes along y-ax, along x-ax, along y-ay, along z-az. And if this point has the coordinate ax, ay, az. So how we can write this? We can write it ax, ax hat, ay hat, az hat. Generally, the unit vector is written by the small letter with the cap on its head. So, this is the example of the Cartesian coordinate in the 3D. You can think about the room or you can think about your mobile. These are all the example of the Cartesian coordinate. So the origin is, this is the origin, and origin we can tell it is the 0, 0, 0. If any point, you can see, if any point is on the x-axis, if any point is on the x-axis, the coordinate will be x, 0, 0. And x, 0, 0 means its position vector will be only ax, x. Similarly, if anything is along the y-axis, if any point is along the y-axis, so we can write what will be the position a. Its position will be ay, ay hat. Similarly, if anything is on the z-axis, this is a which rule? This is the right hand screw rule. You can see from x to y. This is the right hand screw rule. So, if any point is here, that means it has only z component, and we can write az. Now think, if any point is in the corner, what is the meaning of the corner? It is between the intersection point of x and z. So this coordinate will be ax plus az. So this is the coordinate system, and if a point has the three coordinate x, y and z plane, what will be its position vector? Ax, so this will be the position vector. This is the Cartesian coordinate. Now what about the plane? We will move to our before. So if we are thinking about this plane, Which plane is this? This plane is parallel to the x-axis. It has the variable is the z value and y value. So we can give the name of this plane as the x plane, as x is constant. Similarly, think about this top one. Here or the down. If we think about this plane and this plane, the top plane and the down plane. In the plane x and y, only the plane. Check the plane only. X and y both are constant. So we can tell this is the z constant. So we can name it as the z plane, or sometimes we also call it as the xy plane. And similarly, this plane will be y constant plane. This plane is the y constant plane. And we can give the name of this plane is yz plane or x constant plane. The name is the y plane or y constant plane, or we can tell it as the xz plane. In the mobile, this is the xz plane. If it is our y-axis, if this is the y-axis and this is the x-axis, height is the z-axis. So this plane is the xz plane, this plane is the yz plane, and this plane is known as the xy plane. So it is shown when x equals to constant, the plane is the yz plane, y constant plane means xz plane, and z constant plane means the xy plane. So as we told, the range is also the similar. When x is constant means x value may variable from minus infinity to plus infinity, y value will be minus infinity to plus infinity, z is also minus infinity to plus infinity. So we can see that diagram in the 3D. In the 3D diagram, you can see the x, y, z. This is the origin, and all the three planes will cut at a single point. So what is the position vector? Already I have discussed in 2 classes on this. Position vector means when we are telling about the position of a point, it has 3 coordinates. What are the coordinates? The coordinates are x, y and z, and we can write the point along the help of its x, y, z axis. This is known as the position vector. So what is the position vector? Position vector in the Cartesian coordinate can be written as if A is equal to 4, 3. What is this? This is a 2D or 3D? This is basically the 2-dimensional. It has 2 value x and y. So what are the unit vector? How to draw this? X, y, point is 4, 3. So what will be its vector? The vector will be A. If we write in the using the bold, it also means it is the vector quantity. A is equal to 4ax plus 3ay. If we think about the another point, x, y and z, and the point value is 4, 3, 2. What will be the position vector? The position vector will be 4ax hat plus 3ay hat plus 2az hat. So this is very simple to tell the position vector. Now if we have 2 points, one car is moving from the institute to your home. So one point is institute, another point is your home, and how to calculate the length? So this is called the distance vector. First, when we have to calculate the distance, we have to understand 2 points, starting point and end point or terminating point. We have to understand 2 points, starting point and end point, and we have to connect it and give the arrow. A is the starting point and B is the end point. Next, subtract each coordinate of the starting point to end point. From starting point to end point, from end point to starting point, we have to subtract. What is next? Next is the add the 3 components to get the distance vector. Add the 3 components. Actually, I have written one thing wrong. Subtract the respective coordinates from end point to starting point. I wrote it opposite. Actually, from end point to starting point. What does it mean? If the vector B has 3 coordinates, Bx, By, Bz, and A has also 3 coordinates, Ax, Ay, Az. If we have 3 coordinate system, okay, we are in this point, sorry. So, if we have to calculate the value, how to calculate according to this point? According to the point, end point means Bx should be Bx minus Ax, By minus Ay, and Bz minus Az. So we have to subtract each point, then add the 3 components, means Bx minus Ax plus By minus Ay plus Bz minus Az along with the unit vector. Then the magnitude of the line is the distance of the length of the distance, and we have to calculate the unit vector to understand the direction of the line. So let's do one small problem on this. Say we have a point as 1, 2, 3 and another point is origin. So this point is P, this point is A. Some car is moving from A to P. So what is the end point? End point is P. What is the position vector of P? P vector is Ax hat plus 2Ay hat plus 3Az hat. What is the position of A vector? A vector is 0Ax hat plus 0Ay hat plus 0Az hat. So what is PA? PA is the distance between them. And what will be the PA line? Means end point minus starting point. So it is Ax hat plus 2Ay hat plus 3Az hat. And what is its magnitude? Its magnitude is 1 square plus 2 square plus 3 square. So this is the length of the distance. What will be the unity vector? Unity vector means that what will be the unity vector? Unity vector will be the total point divided by its magnitude. Next important thing is the differential element in Cartesian coordinate. What is the meaning of differential coordinate? If we move a point for a very little amount, we can tell the length will be changed. Say one position is XYZ. If we move the pen little bit, so the distance between the first position, it is here. If we move, so the distance between the first position and second position is known as the differential distance. And differential distance is written by dx, dy, dz. So when we are thinking about the surface, the surface of the xy plane will be dy xy plane, dy dx. And one more thing, the direction of the surface is always normal to the surface. If dy dx plane we are thinking, the surface will be along the z axis. If we are thinking about the yz plane, the direction of the plane will be along the x-axis. Now you may ask me, what is the meaning of the direction of a surface? Actually, if we keep it anything, say give a simple example, if we give some fire on the floor, what will be the direction of its flame or the smoke? It will start from the xy plane to upwards. So the general tendency of it to go in the upwards. So according to the 90-degree area. And what is the volume? The volume is basically dx, dy, dz. And volume don't have any direction. It is a scalar quantity. The line and the distance is a vector quantity. Now we will move to our next coordinate system, that is the cylindrical coordinate system. When we will use the cylindrical coordinate system? When the system has the cylindrical symmetry. What is the meaning of the cylindrical symmetry? If we think about an underground cable, a overhead line, the shape is like a cylinder. So there we can use the cylindrical symmetry. And we can give the point using the three coordinate. One is r radius, one is the height z, another one is the angle. With respect to origin. This is called the phi. So a point in a cylindrical coordinates is represented as r, phi and z, where r is the radius of the displacement, which is told as the radial displacement. Phi is the azimuthal angle, or we can tell the angular displacement. Something is moving with an angle, with a circle. So this is the angular displacement. In the case of the motor also, we will tell about the angular displacement. Another one is the vertical displacement. Vertical displacement means the height. The height is equals to the vertical displacement. If we think about an aeroplane, if the aeroplane is in certain height, it has also three. One is the height, which is known as the pitch. Another one is the roll, means its radius. Another one is the angle, which is known as the pitch. So this is the diagram of a cylindrical coordinate. As we told, this is the cylinder. This is the cylinder. This is the radius of the cylinder. We can write with r or rho, and the unit vector will be rho hat, will be either r hat, or we can tell it as the r hat. The unit vector is a rho hat. If we are thinking about the angle, say something is moving through the circular nature. So what is the unit vector? A phi. And when we are thinking about the height, we are thinking about the length. If it is horizontal, it is length. If we keep it vertical, this is height. So the height is z, and we can write it as the az. So cylindrical coordinate has also three unit vector, a rho, a phi, a z. And what is the range? I have not told the range till now. What is the range of the rho? As the rho is the radius. So what is the range of the rho? The range of the rho radius is 0 to infinity. Radius can't be negative. What is the range of the angle? The angle range, angle is a circular in nature. So it is 0 to 360 degree, or we can write 0 to 2 pi. And height, what is the length of, what is the height range? It is, height means similar to the, unlike the Cartesian coordinate, it can go upwards, it can go downwards. So this range is minus infinity to plus infinity. So these three are the range of the three axes. So you can understand the axis. So xz plane, what is the meaning of xz plane? It is the, this is the, when we are thinking about the cylinder, this is xz plane and zy plane. So this is the plane, this is the plane. What are the coordinates? r1, phi, z1. So this is the 3 points of the cylinder. If we think one point is here, so this point has the radius, height and the angle. If one point, if we think about one point here, so it has some radius, it has some height, it has some angle. So all the points have the 3 axes. So already these are, I have told, the range of the variables, the radius is 0 to infinity, phi is 0 to 2 pi and z is minus infinity to plus infinity. And what are the coordinates? What are the unit vectors? Unit vectors are AR, A phi or AZ, or we can tell A rho, A phi, AZ. As it is written in the bold, we are not using any cap. But while writing, you should write the cap. And what is the magnitude of the line? The magnitude of the line is AR square plus A phi square plus AZ square. What is the magnitude? The coefficient of R component square plus phi component square plus Z component square. The magnitude of any position. So when we are thinking about the plane, please try, this is the cylinder. So how many planes? This is the one plane. Please check. This is the one plane, circle. So when we are thinking about the circle which is constant, the phi is actually constant. So we are getting one plane. First one is the radius r is constant. We are changing from big to small. If it is big, the point will be shifted. Another one is the, if we change the radius, what will happen? If we change the radius, maybe more radius means one big cylinder. So this is the constant angle plane. Another plane is the, if we think about cut it, we will get the plane, and this is the Z plane. So we are getting 3 plane. When is the r constant? R constant means, radius constant means the body of the cylinder. Phi is constant, phi angle is constant. Angle is constant, we cannot show it. Phi is constant means we can get either small or big cylinder. And another one is the Z. When Z is constant, we will get one circle and another circle. So you can see this, if we are thinking about the inner circle, if we think about the inner circle, this is the inner circle. You can see when it is an inner circle, this is the intersection of Z is equal, R is equal to constant, Z is a constant. So it is a constant Z plane. This top one is a constant Z plane. The down one is the constant Z plane. When we are thinking about the phi constant, means this is the phi constant either here or here or here. If a point is in a straight line, we can tell this plane as the phi constant plane. And what is the Z constant plane? Already we have discussed. And R constant plane means also the circle. So it is the cylindrical coordinate system. In the cylindrical coordinate system, so if what is the meaning of the differential coordinate? If we take one small area, if we cut a very small area from the cylinder, small area means it will looks like a Cartesian coordinate. So this is the small area we have cut from the big cylinder. So what are the small part? One is the dr. Dr means the radius. One is the dz. What is dz? Dz is the height. But whenever we can cutting any angle, we will get the r into d phi instead of d phi. Why? Say we have one. So say we have one circle. If this is the radius is r. The radius is r and the angle is phi 1. What is the distance of this line? This line is r into phi 1. But if the line is here, what is the distance of the line? R. If the angle is phi 2, we can write r into phi 2. So 1 is r into phi 2. If it is not a proper circle, if the phi change, the distance will increase. That's why we write it r into d phi instead of only d phi square. And what is the volume? Volume is r into d phi, r into d phi. Next is dr into dz. R d phi means angle, dr is the height and dz is the dz is the height and dr is the radius. Similarly, already we have discussed, we will get the surface. When the z is constant, what is the surface area? Z is constant, means the circle. In the case of the small, if we take the differential part, means a small rectangle or small cube. So the z plane constant means r into d phi, r d phi, the angle is changing into dr. Why dr? Because the radius is also changing. And what is the direction? If we are thinking about this plane, what will be the direction? Direction is upwards. So direction is the AZ. If we are thinking about this plane, means Z phi angle is constant. We are taking a small point here. In this point, set only this point, we are taking a small area here. So phi is constant. We have taken the point. So here dr is changing and if dz is also changing, but phi is constant. So the direction is a phi. So next important point is the relation between the Cartesian and cylindrical coordinate. What is the relation between the Cartesian and cylindrical coordinate? As we know, the z is constant. We can write z is equal to z. Z is equal to z because z is same. Now think, one point is here. Say this is the circle. This is the circle and one point is here. So this is the point. And the angle from the origin is phi. So we can divide it into the two coordinates. One is along the x-axis and it should be x cos phi. Another is along the y-axis and it will be y sin phi. So we can write, and if the distance is r, x-axis means we can draw only the circle part. So this is a circle. This is the cylinder. I am writing with the green. This is the cylinder. One point is A and the angle is phi. Now we want to convert it into the Cartesian coordinate. X and Y. So if this line has two components, one is along the x-axis, and what is the value? R cos phi, because the radius value is R. It is basically R cos phi, and Y value will be R sin phi. So what is x? X is equal to R cos phi, Y is equal to R sin phi, and Z is constant. Again, if it is the radius, the angle with the origin is phi. If we divide it into the x and y part, x part is R cos phi, y part will be R sin phi. So already we got x squared plus y squared. So this is the conversion from cylindrical to Cartesian. So this is the relation between the cylindrical and Cartesian coordinate. Now, if we think about the relation between the Cartesian to cylinder, the opposite relation. Already we know x value, we know y value. If we write x square plus y square, what will come in x square plus y square? R square from this equation. R square cos square phi plus R square sin square phi. So if we take the R square constant, cos square phi plus sin square phi is equal to R square. So we can write the first relation, R is equal to root of x square plus y square. So root of x square plus y square is the relation. Now if we think about the angle, what is the angle? Angle is, we know cos, we know sin. So y by x is equal to R sin phi by R cos phi. So R cancel out, it is tan phi, and what is phi? Phi equals to tan inverse y by x. We got phi is equal to tan inverse y by x. So let's solve a small problem. Say a point is 3, 4, 5 in Cartesian coordinate. What will be the value in the cylindrical coordinate? So Cartesian coordinate means x value is given 3, y value is given as 4, and z value is given as 5. As we know, the z value is unchanged. So for cylindrical coordinate also, height means z is also 5. Now if we want to calculate the angle, what is the formula? Tan inverse y by x. So what is the angle? Angle is tan inverse y by x. Y value given, x value given, and it is coming 0.927. What is the radius? Radius value is root of x square plus y square. Okay. X square plus y square means it is 3 square plus 4 square means the value is 5. Next is the last one, which is the spherical coordinate system. The spherical coordinate system is used dealing with the problems having a degree of spherical symmetry, a ball. example is a ball, a deuce ball or a normal ball, has the spherical thing. If we think about any charge is also a spherical thing. We can write the point with respect to r, theta, phi. As I told earlier, if we think the sphere, if it is a sphere, r, radius, theta, angle, phi is the height. So we can write the points using the three system. R is the distance from the origin. Theta is known as the co-latitude. Theta, height, is known as the co-latitude, is the angle between z-axis and the vector. And phi, already we have told, it is the azimuthal angle or angular displacement. So we have drawn this is the our mother earth. So in the mother earth, what is the radius? This is the radius. In between, this is the radius. This is the radius. This is the latitude and this is the radius. That's why the value of the latitude is 0 to 360 degree or 2 pi. And the height, how to tell the height? The connecting from North Pole to South Pole. This is the longitude, and longitude is nothing but the height that is written by the theta angle. So, and this plane is known as the equilateral plane, equatorial plane. You can say this is the equatorial plane. So again, similarly, the sphere has also three axes. One axis is x, y, z. This is the when r is constant. This is the radius. One is the height. It looks like a cone. If we think about this surface, it looks like a cone, right angular cone. And this is the half perpendicular. If we cut the sphere in the middle, we will get some half circle. This is the perpendicular to the xy plane. You can understand from this, if it is a spherical coordinate system, the angle theta, what is the angle theta? The angle between the z-axis and the point. If this is the point whose value we want to calculate. If this is the point whose value we want to calculate. So what is the angle? The angle is theta. What is the radius? The distance, the radius is r. So the value is r1. The angle is theta 1. And what is the phi 1? If the thing is make a circle, the angle at this point is known as the phi. So phi is the angle. Again, I will tell you, if this is the point. So if one point is at here, say one point is at here. So the distance, if this is the angle of the point, if the point is here, the angle of this point is known as the angle phi, angle theta, the angle of the z, angle of the point with the z axis. If the point is here, the angle with the x-axis, if this is the x-axis, the angle with the x-axis is known as the phi and the distance is r. So what are the range? The range is, as this is the radius 0 to phi, the radius is 0 to infinity. What is the theta? Theta is basically the half circle, because height is the half circle. The longitude of the globe like this, so it is 0 to pi. And the phi is the total circle, azimuthal angle, the total circle, equatorial angle. So this is 0 to 2 pi. So how we will write this? We can write it AR, A phi, A theta, AR along the radius, A phi along the height, along the angle, A theta is along the z axis. And what will be the magnitude of A? If we want to write, the magnitude of A will be root of AR square plus A phi square plus a theta square. So this is the length of the line. Now again we will discuss about the differential surface and length. So when we are thinking about the differential length, what is the length of r? dr. If we increase the length for a small amount, it will be dr. Now if we want to change the height, so as we have already discussed, so it will be r into d theta. Why? Say this is a point. We are changing the point for a small amount. So if the length is r, so what will be this height? It will be r into angle. What is the angle of the z? Z angle, angle with z axis is theta. So it is r theta. What is the angle in the y axis? What is the angle of this? So what is the differential length? If this is the phi, so what is the y axis? This is the height, y axis. Y axis is r sin phi. If this is the radius, angle is phi, the y axis value, if this radius is r, the y axis value is r sin phi. So this is r sin phi and the variable is d phi. So this is the differential length. What is the volume? Volume is r into r sin square theta, dr, d theta, d phi. We have three variables dr, r into d theta, the height, r sin phi, r sin theta, d phi, the angle. So these three are the main differential surface. So what are the surface? So this is the line. We have talked about the line and volume. Now we will tell about the surface. What are the surface? When the radius is constant, first we will start. The radius is constant. So what are the variable? R sin theta d phi. What are the variables? The variables are r d theta, r sin theta d phi. So what will be the surface? The surface will be r square sin theta d phi. When the height is constant means r d theta is constant. What will be the value then? R sin theta, this is for the angle, into dr d phi. And when so we got the value r dr d theta. When the d phi is constant. So there are three constant. First is the r constant. R constant means variable is the height and the angle. So what is the length of during the height? R into d theta. And what is the value along the angle? R sin theta. So it is coming r square sin theta d phi. And what will be the direction? Direction will be along the r axis. As I told, the direction is the which is basically the perpendicular to the axis. Now last one, the relation between the Cartesian and spherical component. So when we are thinking about the component, so there should be some relation. So if this is the P point, and its position is x, y, z, or we have to change it into the r theta, r phi. So P position has the radius is r. This is the radius from the origin is r. Theta is the angle of z with the position of the point. This is theta. Phi means the angle along the circle. So first we will divide it, as this is the z, we will divide it into the two axes. So as this is the angle, so it will be the r, this z will be the r cos theta. So z is equal to r cos theta we got. Now think, if it is the cos theta angle r cos theta, some angle will be r sin theta. So the r sin theta comes in the circular plane. If we think only the plane is basically, or if we think about the plane similar to the cylinder, the circular plane, this is the circular plane. So another point, this is the xy plane. If z is 0, we get the xy plane. So another part will come in the xy plane, and the value is r sin theta. R sin theta. Now, what is the angle of this axis with the x-axis? The angle is phi, because this is rotating. So, what will be the value? Again, we can divide it into two axes. So, it will be r sin theta cos phi. So, y should be r sin theta sin phi. So, what is the relation we got? X is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta. So, we got the relation. Now, if we calculate the x square, so what is the relation? This is the spherical to Cartesian. If we want to do the vice versa, Cartesian to spherical, what we will do? First, we will add x square plus y square plus z square. So, what is the value? R square sin square theta cos square phi. Okay. R square sin square theta cos square phi plus r square sin square theta sin square phi. R square sin square theta sin square phi plus r cos square theta. R square cos square theta. Now, if we take the r square sin square theta common, what is the value? Cos square phi plus sin square phi. What is the value? The value is 1. Plus r square cos square theta. So, it is again, as this is the value is 1, r square sin square theta plus cos square theta. So, it is r square. So, what is r? R is equal to root of x square plus y square plus z square. So, this is okay. Now, what is the value of phi? We know. So, how to calculate the value of phi? Phi is always about the only xy axis. What is phi? In the case of cylindrical, in the case of when I will tell what about the phi, phi is the angle, and it is same for the cylindrical, and it is same for the cylindrical and the spherical. So, in the case of the cylindrical and spherical both component, it is all about the xy axis. So, we can write it that y by x is equal to r sin theta sin phi, r sin theta cos phi. So, this is the tan phi. Tan phi is equal to y by x. So, what is phi? Phi is equal to tan inverse y by x. Now, the top portion, the toughest part is we have to calculate the angle theta. So, think about this circle. We don't know the x value, but we know the value of the p position, and we know the value of the z. So, what we can write? Cos theta is equal to z by the distance of p from origin, z by p. We know height by r is equal to the cos theta. So, what is the height? What is the length of the r? Already we have calculated. Length is root of x square plus y square plus z square. So, it is z is equal to root of x square plus y square plus z square. P means this is basically r, no need z by r. The distance of P from origin. The distance of P from origin. And theta is equal to cos inverse z by root of x square plus y square plus z square. So this is the cos theta we got, and this is the relation between the two things. So using the formula we can give the spherical coordinate of the Cartesian coordinate. How to give? So first one is we have to calculate the Cartesian coordinate. X is equal to -1, y is equal to 3, z is equal to 5. What will be the value of r? We know according. What is the value of r? R is equal to root of x square plus y square plus z square. 1 plus 9 plus 25, and it is coming root 35 unit. What is the angle phi? Phi is equal to tan inverse y by x. So it is tan inverse 3 by -1. What is theta? Theta is equal to cos inverse z by root of x square plus y square plus z square. Actually z by r, or we can write cos inverse z by r. What is the value of z? Z is 5. What is r? Root 35. So these are the conversion of the coordinate system. So already we have discussed 3 types of coordinate system: spherical, Cartesian, spherical, and the last one is the Cartesian, cylinder, and spherical. So we have discussed 3 types of coordinate system, and thank you for today's discussion.
Like, share and subscribe. Hit the bell icon for more updates.